Guys, today we're gonna be doing some linear algebra problems, and I'm gonna assume that you guys have some background in row operations. Know for now that you can perform three types of row operations. That is essentially multiplying by a scalar, right? One of the rows by a scalar. You can do one row minus another row or plus another row, minus really just by multiplying by a negative in the other one, and that takes us to the next one, which is essentially adding a multiplied scalar and finally switching rows. So those are the three types of operations that we can do. So let's get started with this. So it wants us to write down a way to convert A to B, elementary row operations, and there are many different ways to do this, but the one that we're going to be doing today is just the most logical one. So we're going to start and we're going to see the similarities and differences. So we know the first row is the same. We know that this and this are the same, so we're probably going to want to start by flipping the R to the R3. Secondly, we're going to get to something like this. And we're going to want to do the following, which is essentially trying to get it to 1, 2, 3, right? And so we notice that if you want a 1 there, the difference between 2 times 8 and 7 is 1. And the difference between 2 times 10 and 8 is 2. And the difference between 2 times 6 and 9 is 3, which is exactly what we have here. So what we're going to do is pretty much just R2 minus 2 times R3 is R3. And so we're going to have 1, 2, 3. We're going to have negative 1, negative 2, negative 3, 4, 5, 6. So you notice that we use this property up here, the one of adding and subtracting here by a multiplied exponent. We used row flipping, and now last but not least, we're going to do multiply by scalar, in this case by negative 1 to R2. And that is essentially going to give us our final B. And so there we go, we got B. That's A. Now, how about B? How can we use elementary row operations to convert B into A? So what operations are this? We should just notice that to go backwards, it's exact same, but backwards. So in this scenario, we're just going to go backwards by pretty much just doing the following, which is multiplying, doing the reverse operation. So in this case, it would be times negative R, times negative R2 again, right? On here we can do, instead of that, it would be, if we do R2, we do an R2 plus, sorry, in this scenario, we would have to do, we could do something along the lines of R3 minus 2R2. So R3 minus 2R2, right? You think about it like that. So this minus 2 times R2, which is going to give us right back here, right? Because negative 1, negative 2, negative 3 times negative 2, it's going to just be 2. It's going to be 4. And this is going to be, so that'll be 6. And if you add this to 4, 5, 6, well, it takes us right back to 7, 8, 9, which is exactly what we have up here. Now going right back to this here, we're gonna have to go back here. We're gonna have to simply do R3 with R2, and ta-da, go all the way back. So yeah, that's something to notice, and it's important later on in inverses when we start dealing with that, if going back and so on. Finally, if we want to do this B here, which is C, sorry, we just did B. C, it says what is the minimum number of row operations that we can do, and it's essentially just 1, 2, 1, 2, 3. Why? Well, because this is 1, this is 2, and this is 3, and these two are fundamentally different signs, and because R3 depends on R1 and R2, so in order to get this to match the bottom, you essentially have to do that, right? There's no way to go about it another way. So that's kind of the whole deal there. Like, if you get here, you notice that it's a negative. So to get from here to here, we had a switch, which is 1. You need that. And then from here to here, we had to subtract 2 times R3, which is the second one. And because there's a negative, we have to do it. So yeah. Okay. Now the next problem. So the next problem is essentially the following.